Okay, so what's our schedule like this week? Does anyone know? Exams on Wednesday, so it means today we should probably review. Unfortunately, I don't have printed copies of the review with me today, but if you don't have access to a printer, after class, or after we finish this part, we can take a look, and I can go get some copies made. Where you should find everything, though, is in Canvas. And if you go to the Modules section, under Lesson 5, there was the recording we did for Lesson 5. A practice test was here, and then there's some more practice tests down here. So what we'll do is we'll work through a few examples, and what you'll see today is the examples I work through. Those are the kind of questions that will be on the test. The ones I don't work won't be on the test. So if there's something in the homework that we don't go over today, it's because it won't be on the test. You won't have to worry about it. And also, these items here, they at one time were actually tests. They weren't just practice tests. They were tests, and then they become practice tests. And the test I gave you will become a practice test for some other group. So they're just basically the problems will change, but what the problems are trying to get you to do will be pretty much the same. And there's also this practice test key here, but that's a static thing that has actually, I'll go ahead and click on it. And we'll see which one it's for as soon as it loads up. Yeah, I think we'll work through some of these, and basically shows you the way we're going to go about solving all exponentials is we're going to graph them. You graph the left side as y1, the right side is y2. Get your windows set so you can see what's happening. You find the intersection, and the calculator gives you the answer. Okay. The reason we don't show you the algebraic way of solving this is because that was taken out of the curriculum. It's something called a logarithm. We don't teach those in this class anymore. At least we don't have to. I could. We could put a week in, but you'll get them when you go to 150. But at this point, the indication is they want us just to focus on how to use the graphing calculator to solve it. You will not be able to do it with algebra unless you have a logarithm. We don't have logarithms, so we just can't do it. So in a way, it's kind of nice. It takes at least a week to maybe 2 weeks out of the curriculum, and we'll just do it with the graphing calculators. If we go down here, so there'll be that. There'll be a regression type problem. And again, if you did well on the one with the linear regression, you'll do just fine on this. If you didn't, it's a time for redemption or to learn how to do it. And basically, we'll walk through this one as well, what buttons to push, but you'll use the stat, and so I'll show kind of how to work through this one. And this is basically more of the same. They just gave you places to draw the graphs. More types of questions, and then basically, so graph, find the intersection, and then the other type of question. So graph, find the intersection, one regression problem, and then the other problems we'll be asking for the starting value or vertical intercept, and we'll point out where that is. And then the other questions we'll ask about either growth or decay. And here's another one that basically is same, just different questions, same test format. And again, this test is kind of short because it used to be exponentials and logarithms. They took out half the test, so I figured why make more problems, right? So we'll just focus on the parts that are here. We'll work through them today. I am live streaming, so it should be recording it good. So that'll be, you can go back and review these things. We'll work a few of these problems. When you feel like you got it, we'll stop. I'll go make some copies if you want to, because it's good to practice these, and then we'll be good to go. Okay. Any questions before we jump into it? Okay. So we've got this. Let's see if this works. Does this work? Yeah. So let's go ahead and start with our word of the day. And I think there was one quiz or one day I missed live streaming, so there is no word of the day for that. Don't worry about it. It's, you know. But if there is a word of the day, you'll want to, yeah, just watch the video and it should show up either at the beginning or at the end. But you can fast forward. If you don't see it at the beginning, fast forward to the end, you'll probably see it there. So what would be a good word for today? Word of the day. Test? Sure. It's a 4-letter word. You could also call it exam, which is also a 4-letter word. So I don't know why 4-letter words are so bad in our language, but they don't have to be. So this is going to be our test day. So I got the calculator up, so we'll be using this kind of towards the beginning. What I think I will do, let's see. Let me just drag over. I don't know if it'll work well. The calculator's a little touchy. So word of the day is test. But this is what we're working on, and basically I may move it in and out depending upon what we need to do. So let me just record that. Actually, back. Before I do this, I probably should take a picture. While it's still nice and clear. Where is that? There it is. And by the way, I don't if you haven't, then that's fine. But if you've been watching the videos, does it help having the screenshots? Has anyone found those helpful? Or okay, so I'll keep doing them. Okay, so this is the first part of the test. We're going to take a look at 3 problems, and each one of them is a little different. So we'll just kind of see. All of these, though, involve using graphing. Now it says using algebra. I really haven't shown you how. If you know how to use logarithms, you could use it, but we'll just skip it for now. If some of you are interested, I could show you probably in 30 or 40 minutes separately, but it's not too bad, but it does take a little bit of instruction, and then it wants it rounded to 3 decimal places. Okay, so we'll start with this first one. Question 1. How do we go about doing this? Well, graphing calculator, we take one side and we'll graph that as a y1 equals, and then we take the other side and we'll graph that as y2. And it doesn't really matter whether you do it y2 and y1 or y1 and y2 or y3 and y7, but just we need them both graphed. Okay, and I'll show you what those y1s and y2s mean. Those are parts of the calculator. So just kind of write that down. 5x to the minus 1 equals 135. So now, switch over to the calculator. That's up front. Let's see if I can. Yeah, this calculator doesn't like being in this screen very well, so let's see. Usually when I switch models back and forth, it starts to work better. There we go. Okay. So I'm going to clear it out. So it should be similar to the keyboard you have, but instead of having a screen up at the top, it has a screen over to the left. So where we go for these is the y equals key. So that's always the first thing we want to start with. If we have stuff in there, it looks like we've actually already done part of this, but something previously done, we just want to clear it out and clear it out. The other thing is, since I've got color, it looks like it's graphing both of mine in red. So I'm going to change one of these, and I'll show you how. See how I can arrow over. Let's see, how do I do this now? I forgot. I think I hit enter. Yeah. And then you can change the colors. we want to start thinking when we go to our graph, it's going to have a certain size window. So we want to think, what do we need to be able to see? Okay, so what does this 135 tell us? What max is 135? There's two kinds of maxes. There's a Y max and an X max. The Y max. So that's the top of our graph. So we just want to remember Y max is at the top, and we're going to have it at least 135. We could go to 150, maybe 200. That'll all be good. X max is over here on the right hand side. It's the maximum X. And then we've got our Y minimum down here, and our X minimum on the other side. It's hard to put X minimum. And a lot of times, if we're not sure, the good thing is we'll just graph it and go. But the only thing we're really sure about is that Y has to be at least 135. We're not quite sure what value of X is going to happen. But remember, exponentials, as X gets big, the numbers get big quickly. So we probably don't need too big of a value of X, so we're probably okay. So we're just going to go ahead. What we're going to do now, clear that out. I'm going to go to Window. Okay. Now there's a lot of stuff here, but again, I'm going to just really focus on X minimum, X maximum, Y minimum, Y max. And for this particular problem, I think I'm okay if I just make my Y max big enough. 150, I think that's good enough. Let's just try 150. We can always come back if it's, we just need to be able to see a good picture of the intersection. So we do that. So far, so good. Any issues here? And again, your numbers can be slightly different than mine. Your windows will look a little different, but at least we got to be able to see Y equals 135 nice and clear. So I hit the graph button, and all of a sudden, you know, yeah, we're way up there. Oh, there's a nice intersection. You see the two different graphs, and again, if you watch it being graphed, you might not have the two different colors, but you could see that's what if we could just get the calculator to tell us that point, we're done with this. We've solved it. And how do we get the calculator to tell us? Second calc. Be nice if they built in like a Siri or something, and you just say, give it to me, you know, but they don't have that yet. So yeah, so right above the trace key, it says calc in probably either blue or yellow or something. So I hit, mine is blue, so I hit the blue key, and then I hit the trace button, which gets us to basically, I think of this as second calc. And if you see down here, let me clear this out. It's supposed to be showing my key press history. So I did second calc, and it tells you right here what I did. Okay. Which one of these tools do you think we're going to use? Number 5, intersect. When we get to quadratics, we'll look at number 3 and 4. We'll bring in those. And then zeros gives us horizontal intercepts, but we'll be just fine. So you can either arrow down or just hit the 5, or you can do both. And notice it's now, it should say calc intersect sort of at the top of your screen. You'll see probably the equation for one of it, usually comes up with y1. You see a little flashing, I call it a spider. It looks like a little spider to me. And it's at a point and it's asking, is this the first curve? And you see this question mark. That means you need to answer this question. Is this the first curve? How do we answer the question? Just enter. Okay. And then it jumps to the second curve, and you see up here y2 is 135. So these are all the pieces you need to learn to look at. It's jumped up to the second one. Is asked, is this a second curve? We want to say yes, so we hit enter. And again, soon you'll just go enter, 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 and you'll be fine. And now it asks a third question. It asks us to take a guess. And what do we say? I spent $140 on you guess. And then it does. It's real quick. We'll see we'll use that tool later when it's important, but in this one, it's just really enter, enter, enter. It'll do it. For exponentials, it's a nice start. Later on, we'll get there. And so what is our answer? What does this tell us right here? that when x equals this number, we have the two graphs will intersect at y equals 135. So it's not that the y is unimportant, but we don't need to list it. When we go to list our answer, all we need to list is the x value. We solve for x. So back over here, we just put x equals 4.048. Notice I rounded it to 3 decimal places. And just like that, I've got my answer. Now if you want to show your work, the way I figure showing the work is you'll see is you just sort of draw a quick sketch of the graph. Now I graph it and that gave me x equals 4.048. So that's about all we can do to show our work. We can show a picture of the graph. You can write all the steps down if you want, but again, a lot of this, it's not so much about showing work, it's being able to do the work. Okay, y1, y2, find that intersection. Typically the hardest part, or the most critical part, is getting a good window size so we can see it, but then it's second calc, enter, enter, enter. It's almost, the next view will do that way. And as long as we have a good window, we'll see the answers nice and clear, and these questions won't cause us any problems. Okay, so far so good? Okay, so we just kind of, what's that?
The graph, my graph is different, but my answer is right.
Okay, so probably your window's a little bit different, because if you change the window, it could be shorter, but as long as you can see the 135, as long as you put the equations in correctly, and you've got this intersection, it's fine. You got the same x value?
Everybody turned around. So this is my right here, straight line.
Yeah, so where's your graph though? On the calculator. Yeah. And we'll try it on the next one, but yeah, you've got to be able to graph these. You have a graphing calculator? Oh, you don't have that kind. Well, I can maybe work with you on that particular app, but definitely want to get one of the TI calculators, because that's the one we have the instruction on how to use. Right. Okay. Right. So. Okay. So what we'll do. See, every time I move this thing, it's not very happy. But, I guess let's go to number 2. So we're back and forth, and it's okay. So I guess I could, I'll take a picture of this. And I'm going to clear this stuff off. Or actually go here. And what we'll do is we'll take a look again, but we'll do number 2 now. Okay. So this one's a little different. It's got the number on the left-hand side, but that's okay. And a little bit more complicated function on the right-hand side. But again, we go put this in the graph, y1, and put the right-hand side in the graph as y2. Clear, clear. So we're going to put in 1,800 for y1, and that's all that goes in there. For y2, and we can do it just like this, or our calculators might make it look a little different, but we've got 27. When we put the parentheses, it knows that that means multiply. So we'll do the parentheses again. We'll put the exponent key. Now you probably get away without putting the, if your calculator looks like mine, but let's go ahead and put the parentheses, 3x plus 2. Okay, so we've got that ready to graph. Again, we want to be able to see this. What are we going to need to do with our window now? To what? About 2,000 be a good shot. And again, we'll just leave the x's as they are, and if we need to move them, we'll deal with them later. Okay, so the first step is, but yeah, the y max is typically on these, we're going to be able to, you know, our answer's got to be up around 1,800. That's what that's telling us. Oops. Let's make it 2,000, not 1,000. 1, 2, 3. Okay. We hit the graph button. This time it drew the straight line first, and then we got the other one, but we can see the intersection, right? Anyone not see their intersection? Okay. Because again, this is the part, and basically the other worksheet I have you do maybe 5 or 6 of these where you're graphing both sides, and it's just taking some practice and getting used to it. Let me just try one thing. If you do run into problems, there's this, I'll show you this sort of quick one. There's something called zoom fit, which is actually down number 10. So I'm going to arrow down. So zoom fit. Okay, so there's this thing called zoom fit. And if you hit that one, it will draw it, but see this one, it didn't do too good of a job. Sometimes it works, sometimes it doesn't. So it made the exponential fit in nicely, but here's our graph down here. Go back to the window. Ooh, wow, yeah, it really messed up. So when it messes things up, I'll show you this. I do a zoom 6, which is a standard. That's the calculator 10, 10, 10, right? And then I go back, and let me just change the Y max. Okay, so sometimes it just changes too many things. We know the Y max needs to be 2,000. Enter, go back to the graph. So this is really the mathematics, yes?
Is it, do you normally just have to change the Y max?
Usually on these, yes.
On these, yes.
Occasionally you do need to change the X,
Okay.
the X min or X max, but with exponentials, generally not.
Okay.
That's why it's nice, because when we were doing logarithms are sort of the inverse, and so then you had to change the X windows, but the Y window you could leave. So it was hard because you were going back and forth.
Okay.
This time, yeah, you're really just worried about the Y max for the most part. Okay. We see the intersection. How do we get it to tell us what the intersection is? Second, calc. There's our tool, number 5. Comes up, and then instead of going through this slowly, how can we do this real quick with blindfold on? Enter, enter, enter. So yes, 1, 2, 3. Just be careful. If you hit it too many times, you might get past your answer or something, and then your answer's not there. But if you get it right, it's telling us when y is 1,800, which is right where it's at. There's our intersection. There's our value. You see it. You see both the number and you see the intersection. Okay, that's what it means for an equation to be equal. Both of those graphs are touching at that point of intersection. Okay, and so
My graph isn't like your graph, but my answers are the same.
Okay, because you must have made your Y minimum about 2,000 as well,
Okay.
because your graph is nice and centered.
Okay.
Or actually, no. Wish I could show everyone. You didn't make your Y max 2,000.
So that's why. Okay.
Yeah, so you can't notice you don't see the intersection, but it'll still find it.
Yeah, because I didn't find it on here, but I got the answers are right. Okay.
Let me so what she did is, I'll show you that. While I say you have to see the intersection, that's sort of a lie. It's not a mean-spirited lie. It helps you to see it. But watch, I'll move my window back down to 10 instead of 2,000. And I'll show you the graph does appear to be different. It goes like this. Notice I never see y equals 1,800. But if I do go to, since it's graphed now, I go to second calc. When I say 5, oops, not 4, second calc, number 5, I can just go enter, enter, enter. It finds the right intersection for me. It just doesn't show me because it's way up there. Okay. The only time this won't work is if like x had been 15, if the domain's not big enough. But the y window doesn't actually have to fit. But I'd like you to get it there so that you see what you're getting, because otherwise it just looks like magic, right? So it does work. It will give you the right answer. It's just you don't see the answer, and it's just so much more, it feels better when you see, it gives you a visual of what's going on. So that's why it's always good if you can get your window, to a high enough. And again, I could have gone to 2,500, and it would look a little different. I would see, there'd be more above, but so there's no perfect window, but there's, as long as I can see that intersection, that's going to be helpful to me. Okay, and again, that's the mathematics of this part, because you're just going to copy. Part of it is learning how to put equations in correctly. I give you that. That can, But once you've done that, the next part is getting the size of the window correctly so you can see it. And once you can see it, second calc, you just hit enter 3 times. That's all this is going to be to solve it. Okay. And again, you can't solve these algebraically without another week or 2 of instruction on logarithms, which they don't pay me to do it. It's not in the curriculum. It's not going to be on the test, so why should we do it, right? Bring me a coffee or something. I'll do it for you. They're actually kind of fun, and I kind of miss not that we don't have them anymore. But second calc, number 5, and just enter, enter, enter. Okay, and then we just write it down. That's all you got to do for the test answer. Come over and, x equals 1.353. Right? They want it rounded to 3 decimal places. And just to, I don't really get critical if you had 1.352. I'll give you full credit. But Math AS might not, and somebody else down the road. So I'm just seeing, were you able to get, substantially close? And if you put 1.35, you rounded it to 2 decimal places. I'm not going to take anything off, but if you can, try to get it to 3 decimal places. Okay. So far, so good. Okay, so we have one more to do, and then the rest of them are actually going to be pretty quick. So we want 3e to the x equals 7.52. Okay, so let's see if I can. I think we can still, oops, we can't see that.
Show me that little trick that you had to enter in the EX.
Your EX is right there. Okay. So you have to hit second e to the x.
Second. That's why it didn't go in, because I was hitting it,
okay,
and I didn't get that second part. Okay,
yes.
So that's why it didn't go in.
So yeah, timing on this next one is going to be critical. So looks like it's going to disappear a little bit on me. Let's go up here. So we're going to work with this one. I didn't save it, but that's okay. So again, we just look at this. We've got to put this as y1, this as y2. This is going to get, this is about a third of the test, and the other 2/3 are, we'll see, are going to be a lot easier. So the key part is, and there'll be one with an e to the x, so you have to know how to put in e to the x. Typically, this is the one that gets some people, they go, how do I get this in there? I said, well, this is what we did in class. So I go back to y equals, I clear out my equations, and I just need to be able to put in 3e to the x. So 3 is easy, it's right here, but the e to the x is a little hidden. You'll have a calculator key that says ln. That's actually natural logarithm. That's the part we're not talking about. But above it is this little, you'll see this e to the x. Now it's a little misleading when you hit, you have to hit the second button and then the ln button. It doesn't actually give you e to the x, it gives you e to the exponent. Now you actually have to put the x, because you know, maybe there's different things you're going to use. So then we put the x. So there it is, 3e to the x. So make sure, and again, if you forget where it's at, I'll help you out during the test. I'll say, yes.
So when mine comes up, it has like a one little parenthesis.
Yes,
around it.
okay.
So do I need to put the other side?
Yes, you,
on,
well,
or-
yes, that would be helpful, technically. Although I think if you don't, it'll still work okay,
Okay.
but it's best. So the 80, depending upon, yeah, that's actually, you've got an 84, and you've got an 83.
I got what you got.
Yeah, then just put the X and then just put a parenthesis on the other side.
Yeah. So on some of yours, it might look something more like 3. It gives you the caret and the parentheses, and then you just put x parentheses.
That curves.
Yeah, exactly. Yeah. It looks weird because it makes the x big and it doesn't look like an exponent, but that exponent key makes it an exponent. Okay. The 84, if you want the updated operating system, I can update yours. It takes about 4 minutes. I have to find my older one, but and then your calculator will actually look like this stuff.
Okay.
But it's got positives and negatives. They made some advances, and sometimes you, but okay. So far, so good. So we got half. So again, a lot of this is just being able to put the stuff in, but the same thing's going to be in the other class. Okay, and then 7.52. Now this is where, since we remember the last one we did, we had our window up at 2000. Do you think we're going to see a very good picture if we leave it at 2000? No. So this is though, since I think 10 will be fine, I just go to a zoom 6. It resizes to the standard, to the calculator default window, and it's a perfectly good view of things. I see the intersection. So zoom 6 will do it. If you want to go back to the window and change Y max manually to 10, you could, or to 15, or whatever you'd like. So far, we doing good. Okay. How do I find my intersection? Second calc, enter, enter, enter. Right. So you almost will get where second trace number 5, and then yes, enter, enter, enter. And it gives me the intersections at 0.919 if I round it.
After second trace, you hit count 5?
Yes. Second trace gets you the calc, then do number 5. And then what number 5 takes you directly to the window. But you just got to be careful. Sometimes I'm sloppy with and I'll hit the 4. And if you do 4, it's doing something else. It's not giving you an intersection. I think it's finding a minimum or a maximum or something, but it doesn't know the difference. And it'll give you an answer, but it won't be the one you're looking for. But that's why if you see it, you'll see that, oh, wait, it didn't give me that intersection. It gave me something else. Or it gives you an error or something because, again, it needs number 5. Okay? And again, for the answer, all you got to do is x equals 0.919 would be the best answer for that one. Rounded to 3 decimal places. Again, the calculator will give it to you, but you just don't need to know how to operate these calculators. And that's what's going to get you when you get onto 150. They're not going to slow down to take the time necessarily to show you how to do these. They're going to give you these problems and you know how to use a calculator to do it. That's what this class really is about. And you'll see it'll be valuable because we'll be doing the same things with the next few systems. We're solving everything, not really algebraically. We're doing it all with the graphing calculator. So far, so good? Is that okay? So we did 3 problems. There's a practice test in there, and again, before the end of class, I'll go make some copies if you don't have it, but that would be good to just graph them and get some practice with it. Okay. But let's take a look at, there's 3 more things. Actually, I guess this isn't quite a third. 3 more things to look at. Let's look at vertical intercept. I'm going to ask you about that. Rate of growth, I'm going to ask you about that. So let's look at those 2. Those are the 2 simplest. And then the last one is there will be one problem where we ask you to do regression. So we'll have that as a recorded. And again, the regression is just knowing which buttons to push on the calculator to make it happen. We've done it before with linear. We're going to now do it with exponential. Okay. So let's see. Maybe I should just, while we're at it, let's see. Maybe I think this one has, does this one have it? No, there's some other sample problems. So again, when I print it out, you can do those sample problems. Yeah, let's just go ahead and we'll do those last 2 pieces. And I can get this out of the way. Go. And I was not very creative with these because actually I just took these off of the final exam review. So when I was teaching this, they had this final exam review that they broke it down by pieces that we covered. So when I covered this piece, I would just, my tests were actually from the final exam review. So you'll see these again when we go to the final exam. So it's just kind of like, I want you to see each thing I'm teaching you is based on what we're going to have as a final exam. And then we'll just put all the pieces together. Okay, so the first thing is be able to tell, and notice this is exactly what the test will look like. We'll go with this one. Be able to find the y-intercept or vertical intercept. What do we know? What do we always know about a vertical intercept? There's something that was always true about a vertical intercept. Which part? X starts at, yes, good. It starts at the X part is 0. So as soon as they say anything about a y-intercept or vertical intercept, what we know is X equals 0. This means that we can figure, and it's what is y when X is 0. So first of all, if you just come over here, all of these answers are going to have X equals 0 with some number for y. X equals 0 with some number for y. X equals 0 with some number for y. You just got yourself half the points because you got half the coordinates right, just by doing that. Now, this also will hopefully help you remember how you find the X or the vertical intercept. You put in 0 for X. You can plug this in your calculator. When we put in 0 for X, what happens? 2.3 to the 0 power is going to be what? 1. So this becomes 1. What's 1 times 57? So what we just got is y equals 57. And you're going to see that's all there is to it. The answer is actually already there, but you have to remember what part of the thing is the right answer, right? It's not the 2.35, it's the number in front. If you just want to memorize that, that's fine too. But I also want you to remember how to get a vertical intercept. Plug in 0 for X and calculate. So for 6, Plug in 0 for x, and what are we going to get? 0.75 to the 0 is also 1. 1 times 14 is still 14. So that's our vertical intercept. What is the vertical intercept? So sometimes they call them y-intercept, sometimes they call them vertical. They are the same thing. So that's the other thing, is we throw some vocabulary at you, and a lot of times in math we use 4 or 5 different words all for the same thing. Sometimes they have a slightly different meaning, sometimes they don't. In this case, vertical intercept, y-intercept, they have exactly the same meaning. X is 0, what is y? So this one, again, on your calculator if you want, plug in 0 for x. You'll see 1.3 to the 0 gives you just 1. 1 times 38 leaves you with 38. So this one's, once you start getting them, you just look at the answer is right there. Okay? So far so good? Okay. And again, if it's not real clear, go ahead and plug it in and you'll just see it's the, remember, sort of, we looked at exponential equations, or y equals a times b to the x. We sort of said that this value of a is always the vertical intercept. Or the vertical intercept is always going to be 0, comma, a. So we're just looking for the value of a. It's the number in front. Okay. Now this next question, to get full points on it, it's basically the same question. What is the y-intercept of this function? However, there's a second part. A lot of people will forget to answer the second part. So you lose half the points, right? What does the y-intercept mean in this context? So we're going to answer that too, because I want you to know what it means. So what is the y-intercept? 457. And again, it should be listed as an ordered pair, 0, comma, 457. Right? When x is 0, y is 457. That is the vertical intercept. What does it mean? Well, the equation f of x is the population x years since 2003. So when x is 0, what year is it? 2003. So to answer this last question, all I have to say is, well, let's just say it means that in 2003, the population was 457. So it's just knowing how to rephrase it. And I just wanted to get one question like that. What did we say? In 2003, the population, and I'll just abbreviate, and you can abbreviate, was 457. And be careful, it's not in millions or anything, it's just, 457 people. Make sense? Perfect. So there'll be questions. What is the y-intercept? What is the vertical intercept? It's just going to be the number in front on all cases. And there'll be one where it asks you for it, and then it asks you to explain. And whatever year it was, if I said that was 1776, then in 1776, because that's beginning year, there was that many people. That's all it means. Okay, full points. And if you want to get more verbose, you can. More poetic. You could write a whole poem about it, I guess. Okay, so then notice this D4, and it shows up just like this. This is a different type of question. So I had some students, I'll go through, and then they'll just give me the y-intercepts for all of these. I guess they didn't read. But this is not asking for the y-intercept. It's asking for what does the base mean. So it's asking for whether there's growth or decay, and what's the rate. Okay, so this one is one we're going to have to do a little bit of calculation, but not too bad. Remember, with each of these, basically, we're going to take the base part, which is this part, not the front part. It's this number that has the x on it. We're going to turn it to a percentage, and then we're going to subtract 100 from it, and we'll have our answer. That's all there is to this. Turn it to a percent, subtract 100, boom, we're done. Okay, so again, this is just, if you don't get these, it's because you probably didn't at least watch this or something, but that's all there is to it. It really is. So this first one is 1.52. So we take 1.52, multiply by 100, that turns it into a percentage. So that's 152%. We subtract 100%. Why do we subtract 100%? Good, that's what we started, and we're trying to see whether we're growing or shrinking. So this is giving us a positive. Yeah, it gives us a positive 52%. So that's going to tell us growth. And again, I have students do different things. Some will just circle the word growth. That's perfect. And then over here, they'll put the 52%. And you don't have to put a plus or minus because you've told me it's growth. Now you could also write growth out here or whatever you want, or increase. So far, so good? Okay. What do we do for this one? 1.17. So we take the base. And remember, you get a page of notes. So just, write these steps down, and they'll be different numbers, but it's the same questions. 1.17 times 100, that's going to turn it to a percentage. That's 117%. We subtract off the 100 because that's what we started with, and we can find out whether we grew or decayed. Well, we get a positive 17 here. So not only can we see we grew, we have growth, but it is 17% growth. Now some of you will even get to the point where you take the shortcut, you'll just look at this and you'll drop off the 1 and see it's 17% and it's growth. So, and that's fine. But I go through each of the steps so that you know that you're there. This is the one that'll throw people a little bit because they'll look, oh, that's 27%, but it really isn't, because what do we do with it? It's going to be negative, but it's also not going to be 27% anymore. 0.27 times 100 gives us 27%. We'll subtract off the 100% from what we started, and you're right, we're going to get a negative 73%. So the negative tells us we're decreasing, we're decaying, so we'll circle that, and that it's a 73% decay. Now, if you put the negative, it's kind of like a double negative. I'll still give it to you, so I'm not going to get too technical on that. But I don't put it because I said it's decay, so a decay of a negative rate is kind of like a double negative, so it's kind of ambiguous of what it means. So Math AS usually doesn't have you put it in there, so I won't, you're fine, 73% decay. But just make sure you indicated that it's not growth, it's decay. Okay? And again, you can put those over here as well. Right, so these ones are not, we're not finding points. That's, this is the one like that we're doing right here. So these are the percentages, yeah. These are the ones up here that should be points, right? Yeah, so you just had it backwards. Yeah. No, just hold on to it, study for, and then when you're ready, let me know about that. Okay, so far so good. You know how to find intersections. You know how to find vertical intercepts, first part. You know how to explain the meaning of a vertical intercept, starting time. You know how to get the rate, okay? And those are there'll be questions just like that. I think to make it a little easier, actually, I think instead of 3 questions, I'll ask you 6, but they're all the same, because here's the thing is if you miss 1 out of 3, that's like a lot of points, but if you have 6 and you happen to, for some reason, miss 1, it's not as big of a deal. And these should be nice and quick and fast. And I just put different percentages there. You just turn to percent, subtract 100, boom, you got it. So I'll give you a few extras of these because they actually help if I give you more as far as scoring. Sound fair? Reasonable? Okay, so let's take a picture of this one, and it'll sort of... Oh, there'll be one in Canvas. I just took a picture too. So this exact one. So you'll get the video at the end of the video. I post these, and just go into Canvas. Canvas, you'll also be able to pull these up. Okay. So we have one last thing to do. What is that? What else did I say we needed to be able to do?
Regression.
Good. Regression. No aggression, just regression. The opposite of aggression, I guess. So I think I pulled up a, let's see. Yeah, this is the other one. So let me clear off the page. Okay, so this is a good practice sheet here as well. Ouch. This thing has a lot of electrical stuff. Let's see. Nice and big. So there's some other ones in here. The answer key has graphs for these, and so these are good practice ones. I'll print it out and bring some copies back if anyone's interested. Of course, sometimes I go out and everyone's gone, and so which is fine, it's fine. But if you want them, let me know, and we'll make some copies. Okay. So we want to do this one. Now it's lost its table, but we'll walk through this one anyway. See if I can. Come on. Oops. I noticed this one had. Oh, I know. Let's see. Let's do it this way. So this is the data we're going to use. I guess we'll just kind of do so on the thing this is actually set up in a table. What we're going to do on this is we're going to put the top row in as our X's, which we'll list as L1, which stands for list 1. And then at L2, or list 2, we'll put the Y values. And we're going to find a function using the indicated data points, exponential regression. So we'll come up with an equation, and then we'll use the equation to compare with the table. Okay, so let's see, where's my calculator? What happened to my calculator? What I'll do is I'll read off the numbers. I'll put it on my screen. Okay. Make this one a little bit bigger. And change models. Okay. There we go, a little bit bigger. Okay, so I'll just hit clear a couple times. I think that takes us back like to the main screen. So for these questions, for regression, we always hit the stat button. That's where we start. And the process for getting an equation is we'll first edit our data. So we'll go to the edit and then we'll go to the calc. So to go to edit, we just hit the enter key because notice it's highlighted. And if we've had some data already here before, I guess I have, we can clear it out by going arrow up to the top of the list, hit clear, and enter. Notice the list is now clear. Arrow over to L1, go to the top of the list, clear, and enter. And now what I always like to start doing is put the X's in first. So from the table that I'm looking at, I'm sorry that you guys can't see it, I start putting in numbers. So 0, enter. 1, enter. 2, enter. 3, enter. 4, enter. 5, enter. Oops, I didn't like my enter. Oh, I was hitting the shift key instead of enter. Let's go back. That should just be 2 and enter, 3 and enter, 4 and enter, 5 and enter. Okay, it's better, isn't it? And then for our y values, we've got when x is 0, y is 20. 20, not 200. This first month, 24. And then 30. And then 36. 45. And 54. Okay, so this is, again, it's all off the sheet. I've got it in front of me. And just to kind of compare, I'll bring it back over. So that's the data we've got. We've just entered the data 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then the y values 20, 24, 30, 36, 45, 54. And then now it's asked us to find a function, an exponential function. So how do we do that? Not yet. Not second calc. Stat and then calc. Good. So there's a couple places that are similar, like going into the table, and yeah. So there's a few, but they take you. Second calc would take you to the graphing calculation stuff. So it's similar but different. Same thing, only different, right? Very different. So this calculation tool is very different than the graphing calculating tool. And what we did on the last test, you went to number 4, which was linear regression, but we want exponential regression. So we just keep arrowing down, and its number 0 is exponential regression. Again, you could just hit the 0 key, but I like to at least show you. Okay, and I'll show you the 0 key works. It says up here what kind of regressions it's going to be. So if you hit the wrong button and you look up here, it says linear regression. Hopefully you check yourself. Oops, push the wrong one. It'll say exponential regression. List 1, the x's are in L1, L2. So what we do is I just like to kind of hit enter through these, and then we go to calculate, hit enter, and just like that, it's given us our answer. Okay, this is our equation. Now when we go to the test, what we're going to write down is not a equals. We're going to actually write the equation. We're going to write y equals 19.884. That's the A part. The B part is 1.223. So I think it asks for 3 decimal places. If not, and then there's an X up here. A lot of work just to get to that answer, but that's what we're going to be looking for on the test, is that you can put X's in, Y's in, go to stat calc, come down to exponential, and come up with this equation.
question.
Yes.
Is the A in the problem, is that referring to buddies?
It is.
So how can there be 19.8?
There can't, so we would round it to 20.
Okay.
So this is, yeah, so the mathematics
So should
becomes.
we round it because of what they're talking about?
In this case, since we want the function, the mathematical model, we'll use this, and then what we'll do is we'll round our answers, our y values, when we put in a particular.
So just keep it specific.
Yeah.
Okay.
Because 12 months down the road, it may make that difference. Okay. So
So you're saying that the 19.88 is like the starting point?
it is. So it should match up, and you know, on the data, it was 20, and this is, so yeah, we could round this to about 20. But that's the thing with mathematics, is it wasn't exactly exponential, but it's fitting it to it. And you know, when population growth does behave in an exponential function, but you really need large numbers. If you just have your pet rabbit having, you know, a few pet rabbits, well, 20, I guess that's a lot of pets. Anyone got 20 pet rabbits? No, that's called a farm, right? But you know, yeah, you're not going to get it exactly exponential. There might be an extra rabbit per litter or something, but it does. Can anyone tell me though? So it does have this thing. We're starting about 20, right? What kind of a rate of growth is going on here? How fast? What per month? How much are these rabbits growing? With the population growing by?
22.
Exactly. It's about a 22. If you want 22.3, but per month. Multiply that by 12 to get an annual growth rate. That's huge. Got to have a lot of room for those rabbits, right? That's 22.3% growth per month. That's a lot. So, but that's how you can do it. And again, that's really all you'll need to do with it, is come up with an exponential function. Not a lot of work to show, but you do need to know how to do this. And again, it's going to work you towards, as we get down to the end, you'll be able to do maybe multiple regressions and figure out which one fits. When you get to 150, they'll give you data and they'll ask you what's the best fitting function, so that you're going to be moving towards that place of being more of a manager, of making the decisions. So you have to be able to do all the different kinds and maybe do a stat plot to see what the points look like and then fit it in there. We'll just, in this case, we'll just have you give me the equation, and that's all we're going to ask you for on this one. I think the final exam is the same type of question, similar, but what they give you, it's multiple choice, so they give you 4 equations. You just got to pick the right one. And if you spotted this, yeah, you would pick the one with about the same starting value. So, you know, the one on the final, basically, there's 2 that are way off. There's 2 that have the right starting value. And then you just have to do the regression to figure out the difference between the 2. Okay? How's that? Feel good? Feel confident? Because that's all that's on the test, I think. I haven't made it up yet, so I have to, actually I'm going to take these and just remake them. But that's all I'm going to do. So like I said, I'll put probably 6 of each of the 6 vertical intercepts, 6 find the rate problems. We'll do 3 graph and find the intersection problems, just like the front one. One will have an e to the x something. And then there'll be one, like this rabbit one, where I give you some data. You just got to find the equation that fits it. And that's all there's going to be to it.
Will you have any where you give us the rate, but then you want us to find the base?
Would you like that?
No. Sorry, guys.
Fine, thanks.
Okay. Thank you.
That's actually what you'll be using to apply it, but that's what I find is if I go both ways, then it tends to it gets confusing. So if we just go one way, later on when you have to apply problems, you can go back,
Yeah, okay. It does confuse me.
I know,
That's why
but-
was asking if I
yeah.
could-
Yeah, so I won't do it. So it's just going to be, I give you the rate, you'll subtract the 100, so consistently, but then just remember in application problems, if I gave you the rate, then you have to add the 100. But I do find that this works. If I give you just kind of a narrow thing, you practice, when it comes time to do the others, you've actually got that down too. When I mix them together, that's when it's hard to unmix it.
Yeah.
You know, so we'll just stick with that. But I always ask, you know, if you want some, because sometimes I get people, I wouldn't put it on the test, but people, we really want that on the test. How about some extra credit? Do you want, if I put it on as an extra credit? Okay, so we'll put 1 or 2. So I'll give you like 25%. What if I said there's 25% growth? We'll do, so this is all extra credit stuff, but that's, you know, push beyond it. So there'll be a question. Let's see, let's clear this. And let's, so if I say that I have 25% growth and start with 3, write an equation. So how would we do that?
Add that to 100. 25 plus 100.
Why?
Because it's the opposite.
Because it's the growth, right? So we start with 100. Remember, that's why we were subtracting in the other. Since it's growth, we're adding the 25%. So right, it's going to be 125%. Now we need to turn this into a decimal, right? So we divide by 100. So our exponential is simply going to be 1.25 to the x. And then what about this starting with 3? Yes. And actually, since I put this on as extra credit, by reviewing this a little, I think you'll actually even be doing better on the others. But you can also, it won't add stress now, right? You say, I'm going to get a few extra points. So I'll do maybe 3 of these. And again, if I said it was 15% decrease starting at 57, how would I write that equation? So good, we take our 100%, but the rate's negative, so we subtract 15%, leaving us with 85%. Is that right? We divide that by 100, right? Because we got to turn a percent to a decimal. So we see that the base part is just going to be 0.85 or 0.85 to the x. And then what do we do with this 57? Put it right here. It's at the start. So it's kind of, you know, as we practice a little bit going back and forth, it'll come down. But again, no stress on you now because you don't have to worry about it. You're going to get some extra points off of it. That's a good way to go into spring break, you know.
What did you call that?
What did I call that? Writing the equation. So this would just, write an exponential equation is actually how they'll say it. So they'll say this is the process. So they'll just say write exponential and I'll put it towards the end. I'll say these are the bonus questions, so that's the other way is you'll know that that's what we'll be doing. It's good. And that's all there is to exponentials. Again, that's what, you know, by taking logarithms out, they just, I don't know. Now the thing is it gives more of the stuff in 150. So as we get towards the end, I'll, you know, for those of you who are definitely going on to 150, if you want to do a couple days or something, or do some things like logarithms or something to prepare you, I'll look ahead and maybe get a few topics, maybe do an extra day in there where we can review, get you ready for 150.
Do you teach the 150 class?
I haven't in years. I used to teach it every semester, but now I've been working more and more with the development. So I work with 91 and 121, and then you're well prepared now. So then I cycle back down. But what I do is, in fact, I've had a couple students from last semester's 121 come visit me for some tutoring, and because different teachers sometimes, but I could just remind them and they say, oh, now I understand. So 15, 20 minutes we work together, and I remind you about what we did here, and because sometimes it looks different there, and then it's, oh, this is all we're doing, and then so I'm able to work with you still by giving some tutoring, and then circle back and get the ones that are really struggling and get them a good foundation. So, all right. So does anyone want copies of the tests? Okay.
I would like.
You would, okay. I think I might be able to print it from here, I hope. So let me, let's see. We're still live streaming, I think. So we'll cut that off. And thank you, anyone who was watching our live stream. We appreciate your company, even though we don't know you exist, but we know you're there. Oops, that's why. Stop stream. There we go.
Do you have a specific time for 150?
No, because I fit my office hours in basically, but what they do is they email me, and I just would make an arrangement
Yeah.
to fit around your, but because I don't, I just fit it in, and usually it's right before the test they'll come in, and,
Right.
or sometimes it's a little earlier, but
And then Wednesday we're gonna have